Week 1, Real Numbers and Applications. Our introduction to algebra, we're talking about substitution. We often see letters that will represent numbers. Example 1, we're 6y when y equals 7. We just replace the y with the 7. And 6 times 7 is 42. Example 2, 5y over z when y is 15 and z equals 25. We simply put the 5 and the 15 where the y is, 25 where the z is. We multiply 5 times 15, and that gives us 75 over 25. Simplified, that is 3. 3. P plus Q over 2 when P is 2 and Q is 16. I simply replace the P with the 2 right here, the Q with the 16. I add those together in the numerator here, and that's 18. The 2 is in the denominator. 18 over 2 equals 9. Absolute values. Absolute values are the value of a number regardless if it's positive or negative. The best example of this is if you take 3 steps forward, that would be plus 3. But you took 3 steps. If you took 3 steps backwards, that'd be minus 3, but you still took 3 steps. So the absolute value is the value, the count of those numbers. The absolute value of negative 3 is 3. And we have these 2 vertical lines. That means absolute value. Absolute value of 3 is 3. Absolute value of negative 72 is 72. Absolute value of 72 is 72. We can even do this with variables. The absolute value of negative 2x is 2x. I want to be careful. If we have a negative outside the absolute values, the final answer would have a negative. Negative absolute value of 6 would be negative 6 because absolute value of 6 is 6, but there's a negative on the outside. That's the same as negative 1. We're multiplying it by. So that'd be negative 1 times 6, which is negative 6. The last one's a little tricky. Negative absolute value of negative 3. Well, the absolute value of negative 3 is 3. But we multiply times that negative on the outside because we have that negative there. We get negative 3. Some examples here. The absolute value of negative 6 is 6. The absolute value of 325 is 325. Even with fractions, the absolute value of negative 3 5/8 is 3 5/8. Now the addition of real numbers. Well, you remember a positive plus a positive will result in a positive. 5 plus 7, those are both positive numbers, equals 12. A negative plus a negative. Negative 4 plus negative 9 will equal negative 13. What if we have positive and negative? The larger of the two values, if it's a larger negative, then we'll have a negative final value. If it's a larger positive value, then we'll have a final positive. 9 plus negative 2. Well, 9 is larger than negative 2. 9 is larger than 2. So 9 minus 2 is 7. Negative 8 plus 4. Well, negative 8 is larger than 4, absolute value-wise. So it'd be, the final answer, negative 8 plus 4 is negative 4. Now we're going to be using inverses to solve algebraic problems. An inverse is simply the opposite in terms of the sign. The inverse of 8 is negative 8. The inverse of negative 12 is 12. If we have x equals 8 in the equation, the inverse of negative x would be negative 8. Here's some examples. Example 1, 4 plus negative 3 is 1. The 4 absolute value is greater than the 3. So we got a larger positive over a negative, so we have a positive final answer. Now with fractions here, it's the same process. Negative 4/3 plus 2/3. The denominator remains the same, so negative 4 plus 2 is negative 2. The final answer is negative 2/3. Now this next one I want to be careful with. I want to remind you that when we do have fractions with different denominators, we need to term in the same denominator to add subtract. Negative 5/8 plus 1/4 That's the same as negative 5/8 plus 2/8, because 1/4 is the same as 2/8. So 5/8, negative 5/8 plus 2/8 is negative 3/8. Here's another one. Negative 5/6 plus negative 2/9. They're both negative, so we're going to get a final negative answer. But again, we have to have the same denominator. And here's a little trick here. I got different denominators. And people always say, well, multiply the two denominators together. That would give us 6 times 9 is 54. But if you remember your multiples from your multiplication tables, you can come up with an easier answer. Both 6 and 9 go into 18. And on here, negative 5/6, I'm going to multiply times 3 over 3, because 3 over 3 is the same as 1. But that's going to give me an 18 in the denominator. 6 times 3 is 18. The 3 in the numerator. 5 times 3 is 15, so it's negative 15. And then negative 2/9 times 2 over 2, because 9 times 2 is 18, and 2 over 2 is equal to 1. So we're just multiplying the whole thing by 1 again. 9 times 2 is 18. Negative 2 times 2 is negative 4. So my final answer is negative 15/18 plus negative 4/18 equals negative 19/18. The denominators remain the same. I add the 15 and then minus 4, and I get minus 19 right here. Inverse of negative 64 is 64. Inverse when x equals negative 27. The negative x would equal actually 27. We just reverse everything. Subtractional numbers. Subtraction is really basically the same as addition, but we're using negative numbers. Let's go through some of these. Negative 6 minus negative 8. When I subtract a negative, that's the same as adding a positive. So negative 6 minus negative 8 is the same as 6 plus 8 right here. Negative 6 plus 8 is 2. Negative 6 minus negative 10 is the same as 6 plus 10. And 6 plus 10 is 16. Now we got some more fractions here. 3/8 minus 1/2, minus negative 1/2, excuse me. I got to convert those eighths and halves in the common denominator. And I'll just do 8. 3/8 I'll leave alone. But I can convert 1/2 pretty simply in my head, because I know 4/8 same as 1/2. So 3/8 minus negative 4/8 is the same as 3/8 plus 4/8, which equals 7/8. And finally, I'm going to have some little trickiness here in example 4, but I just got to remember, two negatives make a positive. 22 minus negative 18 is the same as plus 18 plus 7 plus minus 42, which is the same as minus 42 minus 27. And the way I do this is I'm going to add up all these positives first. 22 plus 18 is 40, and that equals 47. Then minus 42 minus 27 is minus 69. And 47 minus 69 gives me negative 22. Now we do multiplication of real numbers. This is very similar to addition and subtraction. When we multiply a positive times a negative, multiply mind you, 8 times negative 7, we get a negative number, negative 56. A negative times a negative gives me a positive. And also remember, any product multiplied by 0 equals 0. 12x times 0 is 0. Here's some examples here. 9 times negative 4. 9 times 4 is 36, but it's negative there, so I'm going to have a negative answer, so it's negative 36. And here's a fraction. Now, in fractions, when we're multiplying them, we do not have to change the denominator. You multiply straight across. 5 times negative 2 over here becomes negative 10. And 7 times 3 is 21. That's our final answer. Sounds like we could simplify, but we really can't. Now, we're going to be talking more about exponents towards the end of the course, but I want to show you a little something here. Negative 1 to the 9th power. That's negative 1 times itself 9 times. And what's interesting is when we multiply negative times a negative, we get a positive. So this is 1. Then I multiply these two, and this is a positive 1. and these two, and this is a positive 1. These two I multiply, and this is a positive 1, and I'm left with a negative 1. So 1 times 1 times 1 times 1 is 1, times negative 1 up here gives me a negative 1. And the rule here is if I have a negative number and my exponent is odd, like 1, 3, 5, 7, 9, I'll have a negative answer. If my exponent is even, like 2, 4, 6, 8, 10, and my base is negative, it'll always remain positive. Negative 2 times negative 2 is plus 4, and that's base, that's 2. Negative 2 times negative 2 times negative 2 times negative 2 is positive 16. With an even number of exponents, it always makes it positive. Division. I want to go over a few rules first with division. First, we cannot have a 0 in the denominator. Because we're talking about division, we're basically talking about fractions here. And we can't have 8 pieces of nothing. Anytime you have a 0 in the numerator, it's always 0. The reciprocal is simply the flipping of the fraction. The reciprocal of 6/11 is 11/6. When a number is multiplied by its reciprocal, it equals 1. 5/9, the reciprocal of that is 9/5. 5 times 9 is 45 here. And then 9 times 5, the denominator is 45. 45 over 45 is 1. Any number over itself, even any letter over itself, is 1. The sign always remains the same. If I have 4/5 for a fraction, then the reciprocal is 5/4. And finally, a negative divided by negative is a positive. Just like a positive times positive is a positive, or a negative times negative is a positive. Negative divided by negative is a positive. So there's some questions here. Section 6.1, division of real numbers. The reciprocal of 3/8 is 8/3. Now, what we have here, and I made a little mistake here, we write each step as division multiplication. 3/8 equals 3 times, that shouldn't be 1 over 18, it should be 1 over 8. And then 7/8 divided by negative 1/2. Remember, whenever we divide something, we flip the second component. 7/8 divided by negative 1/2 is the same as 7/8 times negative 2 over 1. 7 times 2 is 14. 8 times 1 is 8. So I got negative 14 over 8. And that can be simplified if I just cut it in half on both sides to negative 7/4. Now, you've heard these terms before, but we're actually going to use some of them. The commutative property is a plus b equals b plus a, and multiplication, a times b equals b times a. The associative property is a plus the components of b and c equals components of a plus b plus c. So multiplication, a times the components of b and c equals components a times b plus c. And then distributive property, we're going to use quite a bit in factoring. A times components of b plus c is a times b plus a times c. And you see the examples I gave to prove it. And then a times b minus c equals a times b over a minus c. And then factoring is basically the distributive property in reverse. 5x minus 10, I can pull a 5 out of both of them. And that means that 5 times x minus 2. And I'll multiply back. 5 times x is 5x. 5 times negative 2 is negative 10. Let's look at some of these problems here. 4 times x plus 3 is 4x plus 12. 4 times x is 4x. 4 times 3 is 12. 9 times 6m plus 7. 9 times 6m is 54m. 9 times 7 is 63. And like I said, all I am doing here is multiplying these out all the way across. 9 times 6m is 54m. And then 9 times 7 equals 63. Factoring is reverse. I recognize this, and this is where, again, remembering your multiplication tables helps. Factor 30 plus 5y. I know I get a 5 in both those. 5 goes into 36 times. and then 5 goes into 5y one time. And I could write it as 6 plus 1y, but if there's just a 1, we usually just leave the letter by itself. 18a plus 24b. Got two different variables here, but I know something going both of those. A 6 goes into 18 3 times. 6 times 3 is 18. That leaves an a. And then 6 goes into 24 4 times. So 6 times 4 is 24. So it's, when I split this apart, distribute this, 18a plus 24b equals 6 times the component of 3a plus 4b. And number 5 is simply just remembering, I got 12x plus 2x. I have the same variable. I can add them together. 12x plus 2x is 14x. Order of operations. We want to do everything in the parentheses first and then work our way out. Now this first part is pretty simple. 5x plus the component is 2x plus 3. I'm adding everything there. So it's just 5x plus 2x plus 3. 5x plus 2x is 7x plus 3. Now subtracting. I want you to remember, we're subtracting everything within those parentheses. That 3x minus the component is 4x plus 2. So it's going to be 3x plus negative 4x minus 2. So we're subtracting everything. 3x minus 4x is negative x. We're left with minus 2. So the equivalent expression of negative component 8x plus 4, that's same as negative 1. Negative 1 times 8x is negative 8x. Negative 1 times 4 is negative 4. So I get negative x minus 4. Remove the parentheses to simplify. Again, we've got a negative here. And that means we're subtracting everything within this. So it'll be 4y minus 2y minus 5. 4y minus 2y is 2y. We're left with minus 5. So the final answer is 2y minus 5. 3a minus 9b minus 1 times component 4a minus 8b. So let's multiply this, do the parentheses first as I said. Let's multiply this negative 1 by this 4a minus 8b. Negative 1 times 4a is negative 4a. Negative 1 times negative 8b is plus 8b. So now we can put these like terms together. 3a minus 4a is negative a. Negative 9b plus 8b is negative b. So my final answer is negative a minus negative b, or minus b.